Hello and welcome to my first math or science video from my new job in Houghton, New York at Houghton College. And I am doing this video on Avogadro's number and the mole, which sounds like a Batman Robin team, right? Avogadro and the mole. Maybe we can work on that. But anyway, Avogadro, as you might know, was a fellow who lived in the 1800s, I believe it was. Who came up with this concept of the mole. Now, this is not a mole as in, kind of a mole. Oh, I see a mole. That's not what we're talking about here. And no animals have been hurt in the filming of this video. A mole here comes from, actually it's come from a Latin word, whose meaning I have forgotten, which is horrible because I have taught Latin in the past. But anyway, basically, we're talking about a way of grouping large numbers. Now, atoms are freakishly small from my perspective. I'm, a green giant. I'm this huge being. You are too, no matter how tall you are. In fact, moles are huge beings when it comes to atoms and that size of things. I can't even comprehend how small atoms are compared to me. And so when you're dealing with that large of a quantity of things, people like Avogadro wanted to come up with a way to kind of group them. And we do this. We have to. Our brains are so small. We have to come up with ways to group things. And so a dozen, is a way of grouping grouping eggs by 12. A kilogram groups things by thousands. 1,000 grams, groups of 1,000 grams. Because a gram is really pretty small for the kind, I'm freakishly heavy when you think of grams. And so we come up with these bigger units to try to group large amounts of things that our puny little brains can't handle. And so when we're grouping atoms and molecules, this guy named Amedio Avogadro came up with this number. Now, I'll explain a little bit why he chose this number. It's not the kind of number that makes sense to me. It makes sense in terms of the science. And so a mole is basically 6 times 10 to the 23rd power. 10 to the 23rd, of course, means 23 zeros. So 6, 0, 2, 0, 0, 0, 0. I mean, that's not exact. But let's just say 6. 6 with 23 zeros after it. That is a mole of something, an amount of something. Again, don't think of a little animal. We're not talking about that. It's a large number of atoms. And of course, you can use it for anything. A mole of atoms, a mole of molecules, a mole of ions, a mole of Nissans, which is impossible. There have not been a mole of Nissans produced at this point. Never will be, I'm quite certain. It's a very, very, very large number. Where did it come from? Well, before we get there, we abbreviate mole MOL. Why not just put the E, right? I don't know. But MOL is the abbreviation for mole. And then capital N with a sub capital A is Avogadro's number. That's what that stands for. N sub A is Avogadro's number. Okay, now what is it? It is basically keyed to the number of atoms that are in 12 grams of carbon-12. Carbon-12, what's carbon-12? It's a good question, right? Carbon-12 is basically, as you recall, C stands for carbon, and 12 is the atomic mass of the nucleus. So I can't remember whether we've talked about isotopes yet in this series of videos. By the way, I'm following the order of things in Brown, Burston, LeMay, and Murphy in their chemistry, the central science. That's the textbook I'm following. And we're in chapter 3, section 5. I think that's what it was. But anyway, although all carbon atoms have 6 protons in their nucleus, there are some carbon atoms that have 6 protons and 6 neutrons, and there are some carbon atoms that have 6 protons and 8 neutrons. That's carbon-14, which is radioactive, by the way. It's how they date some things, by carbon-14 dating. That's not important right now. So carbon-12 are versions of carbon, isotopes of carbon, that have not only the required 6 protons in the nucleus, but 6 neutrons. It's a very stable atom. So there are 12 particles in the nucleus of carbon-12, and 12 grams of carbon-12 is how Avogadro basically came up with this number of 6.02 times 10 to the 23rd power, because there are 6.02 times 10 to the 23rd carbon atoms in 12 grams of carbon-12. So that's where the weird number 6 times 10 to the 23rd comes from. Avogadro used nature to generate this number. Okay, so what is the molar mass? Well, the molar mass is the number of grams per mole of something. So the molar mass of carbon is the number of grams per mole of carbon, which is 12, of course. But anyway, and by the way, as I said, carbon-12 has a molar mass of 12 grams because there are 12 grams per mole of carbon. And so, and when you're dealing with a pure isotope, like magnesium-24 has a molar mass of 24 grams. In fact, we can generalize this and say that the mass of a single atom, that is the atomic mass of, say, carbon, that has the same number as the mass of a mole of carbon. Now, it's not the same quantity, right? You're dealing with atomic mass units, 12 atomic mass units for carbon-12, and 12 grams, which is huge in comparison for a mole of carbon. Magnesium has 24 AMUs, 24 atomic mass units on the atom. But a mole of magnesium has 24 grams, which is much, much more. So it's a different amount of stuff, but the same number. The same number for the atomic mass as the molar mass. Okay, so there you have it. What are some little details that we want to work in here? Okay, so for molecules or ions, etc., so take water, H2O. The formula weight, which is oxygen is 16 atomic mass units, hydrogen is 1, so 16 plus 2 is 18. So the formula weight of water per molecule is 18 atomic mass units. So the molar mass of water is going to be 18 grams per mole. It's going to be the same number, even though it's a much different amount. Also remember the difference between atomic mass, which is like carbon-12 has an atomic mass of 12, and like the atomic weight that you see on the periodic table. On the periodic table, the atomic weight is the average of the mass of the isotopes, right? By the way, it's not properly named. It shouldn't be called atomic weight, but I won't go into that. It is what it is. So when you look at the periodic table and it gives you the atomic weight of carbon, it's not going to be just 12. It's going to be 12 point something because it's averaging together the different isotopes of carbon in relation to how frequent they are. Carbon-12 is the most frequent, so it's going to end up being around 12. But when you put in a little carbon-14 here and a little carbon, I think there's a carbon-11, a little of that over here, and you don't get a pure 12 when you do the atomic weight. If you don't understand what I'm saying, don't worry, it's a different video. But atomic mass, remember there's a difference between atomic mass and atomic weight. Okay, conversions to end up this. So how do you convert from, so I have 15 grams of carbon, how many moles is that? Or I've got 15 moles, I've got 12 moles of carbon. What's the mass of that? How do you convert it? Well, it's all a matter of following the units, the factor label method. And I know I have a video in here from chapter 1 on the factor label method. So if I have the mass and I want to find the moles, I multiply the mass times moles per mass, which is the molar mass of it. And then the mass cancels out because this will be on the top and that'll be in the bottom, and I'll be left with moles. Or if I have the number of moles, then I multiply it by the mass per mole. And then actually, this is the molar mass per mole. This is the 1 over the molar mass. But anyway, the inverse of it. So basically, moles will cancel out in this one, and you'll end up with mass. Follow the units. If you know how to cancel out the units, you can figure this out. What about if you want to exchange between the mass and the number of particles? So if you divide the mass by the mass per mole, you'll end up with moles. Mass divided by molar mass equals moles. So let's say you want to find out the number of molecules. Then you take the number of moles and you multiply it by Avogadro's number, which is the number of atoms or molecules per mole. Moles cancel out, and you're left with the number of molecules or the number of atoms. So there you have it, a little bit with conversions. And with that, we have covered this section from Houghton, New York. So onward with chemistry.